Yeah, good morning students. So the next is we'll move on to the next topic. It's about the field area attributes here. The field area attributes means the picture component any boundary inside of a polygon has to be filled with some color or with the pattern that is usually called as an field area or field area here. Approximately a curved surface with polygon facets is sometimes referred to as an surface tessellation or fitting the surface with a polygon mesh here. So there are some whenever if you want to fill the polygon areas here, polygon it's a plane figure specified by set of 3 or more coordinates here position called vertices that are connected in sequence by straight line segment called the edges or side of the polygon. Examples of polygon includes triangles, rectangles, octagons and all. So here there are actually the two types of the polygon, that is one is convex polygon and concave. So the convex polygon means if all the interior angles of the polygon are less than or equal to 180, this is called convex, and concave means if any one of the interior edges of interior angles of an polygon is greater than 180, then we said it is an concave polygon. So now next is how to test the what type of polygon is. In order to test the type of an polygon, we have some several steps here. The first one is, suppose assume that we have one complex object, that we need to divide that complex object into several polygon, and then after dividing that we need to identify what type of polygon, whether it is an convex or concave. Then if it is an concave, then again we need to split that concave polygon into convex polygon, and then after that if it is an convex polygon we need to split it into the triangles, and finally you are going to render the object here. Suppose first step is how to test a concave polygon. In order to test a concave polygon, so there are actually the two methods are used. One is the simple method and another one is the edge vector method. In the simple test, concave polygon has at least one year interior angle greater than 180 degree, then it is an concave. Then if you extend some edges, if the edges are intersect with each other, then it is an concave here. Then if you draw a pair of points, a pair of line segment within an polygon here, if that line segment it's what exactly touches the boundary of an polygon, then it is in concave here. So the next is we'll have the another type called the edge vector cross product test here. So here how this will work is, first we need to set up the vector for each edge of the polygon, starts from one vertex of the polygon and move in anti-clockwise direction, and the vector is in the direction of the movement. Then we need to compute the cross product of adjacent edges. If all the cross products give same sign, then it is in convex polygon, otherwise it is in concave here. This is one of the examples of how you are going to specify that. Here I has given actually the diagram. Here in this case V1 to V2 is the vertex. These vertex are moving in an anti-clockwise direction, and these are all the respective edges here. So when you compute the cross product of the edge vectors, you can use the formula by using x is equal to a2 b3 minus a3 b2, y is equal to a3 b1 minus a1 b3, z is equal to a1 b2 minus a2 b2 here. So then after that, after computing the edge vector here, so suppose if all the results of the edge vectors gives the same sign, then it is an concave polygon, convex polygon, otherwise it is in concave here. So here in this case you can see E2, E3 cross E4 which is less than 0, then it is with respect to the Z component, then it is in concave polygon here. So this is the first step here. Then after that, after obtaining the concave, once if we identify the polygon is in concave, next step is we need to split that concave polygon into the convex here. Again there are two methods are used, that is one is the vector method and another one is what exactly and another one is the rotational method here. So in case of the vector methods, first we need to form the edge vectors. Then given the two consecutive vertex position Vk and Vk plus 1, we define the edge vector between them as Ek is equal to Vk plus 1 minus Vk. Then calculate the cross product of successive edge vectors in order around the polygon perimeter. If the Z components of some cross products is positive while other cross products have negative Z component, then polygon is concave. We can apply the vector method by processing the edge vectors in counterclockwise order. If any cross product has a negative Z component, the polygon is concave and we can split it along the line of the first edge vector in the cross product pair here. So this is how actually you can see here with respect to that E2 and E3. So here actually it is giving an, it is in concave polygon, then we need to send a right line segment here. That means compute the edge vector. Here in this case you can see E2 and E3 will have actually the negative component as Z component as the -2. So that since the cross product E2 E3 has a negative Z component, then we need to split along the polygon line vector of E2 here. Okay, so this is what we have done with respect to this. Thank you.